When you really think about someone saying, let's invent a telescope that can see back to the Big Bang, like,
this isn't just another deep space discovery. Something far stranger is unfolding.
And all these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
The James Webb Space Telescope has peered farther than any instrument before.
One of the key things that the James Webb Space Telescope is designed to do is detect the very first stars and galaxies that were born in the very early universe.
And what it found doesn't fit into our understanding of the cosmos. Bright, massive objects where there should be darkness.
The galaxies in the merging galaxies, we now see gas and dust which is being heated up in the collision between those galaxies.
Structures forming faster than the laws of physics allow. Even Nobel Prize-winning scientists are stunned. The early universe is behaving like a different reality altogether.
Is finding things that we didn't expect, that we can't explain, because that means that...
Could it be another universe? Or are we standing at the edge of a cosmic illusion? What lies beyond the veil might not only change astronomy, but it could change everything we believe. A universe that shouldn't exist. When the James Webb Space Telescope began sending back its first deep field images,
every image is a new discovery, and each will give humanity a view of the universe that we've never seen before.
scientists expected to see faint signals of the first galaxies, slowly forming after the Big Bang. But instead, they saw something astonishing, bright, well-formed galaxies that had no business being there. One particular yellow blob stood out. At first glance, astronomers thought it couldn't be that far away. It was simply too bright, too massive. The early universe, just a few 100 million years old, shouldn't have had time to build something like that. But then came the spectroscopic data, the real test. And the results were shocking. That glowing blob wasn't a nearby imposter. It was, in fact, one of the most distant galaxies ever recorded. Its light had traveled for more than 13 billion years to reach us. And it wasn't alone. All across Webb's early images were similar bright objects, scattered like cosmic seeds. These galaxies defied every prediction. They appeared fully developed, packed with stars, and incredibly dense. According to our standard models, galaxies in the early universe should have been chaotic, small, and dim. These weren't. They looked mature, organized, and old, as if the universe had fast-forwarded through its early growth. The question emerged quickly and sharply: how could these galaxies exist so soon after the beginning of time? To form something that big, you'd need stars. To get stars, you'd need dust and gas to collapse under gravity. And that takes time, a lot of time. The early universe didn't seem to have. Astronomers were puzzled. Could this be a flaw in the telescope? Was the data wrong? But the patterns repeated across image after image, and independent teams confirmed the findings. This wasn't a mistake. It was a mystery. And so, one of the universe's oldest questions resurfaced in a brand new form. How did we get here? Because if these galaxies are real, and the evidence says they are, then the early universe was doing things we still don't understand. And that might mean we don't understand the universe at all. The theory is cracking. For decades, the Lambda CDM model has stood as the cornerstone of modern cosmology. It's a framework built on the idea that the universe is made mostly of cold, dark matter and driven apart by dark energy. It explains the formation of galaxies, the expansion of space, and the distribution of matter in the cosmos. Until now, it seemed unshakable. But the James Webb Telescope has started to pull at its seams. The newly discovered galaxies are not just curious outliers, they are too massive, too bright, and too early. According to the Lambda CDM model, there shouldn't have been enough time or material for galaxies to become that large so soon after the Big Bang. The math doesn't add up, the energy doesn't balance, and the timeline is broken. To form such galaxies in only a few 100 million years would mean converting nearly all the available ordinary matter, hydrogen and helium left over from the Big Bang, into stars at lightning speed. But our models say that's impossible. Even in the most aggressive star-forming regions we've ever observed, the conversion rate is slow and inefficient. Nature doesn't rush. Some researchers tried to tweak the numbers, adjusting the rate of star formation or the amount of initial material. But the changes required are so extreme that they break other parts of the model. It's like fixing a tear in one place only to create a larger rip elsewhere. The problem isn't the measurements, it's the foundation. Even Nobel Prize-winning scientists are beginning to speak openly about these cracks. Some suggest that dark matter may behave differently in the early universe. Others propose entirely new physics concepts we haven't yet imagined. One radical idea gaining traction is that we may not be looking at early galaxies at all. These objects might be something else entirely. If the model fails at the beginning, then everything built upon it becomes shaky. And if our most trusted theories can't explain what we're seeing, we may be standing on the edge of a scientific revolution, one that could rewrite the story of our universe from the first page. Galaxies or something else? At first, scientists assumed the James Webb Telescope had simply captured early galaxies that somehow formed faster than expected. But as the data poured in, that explanation began to unravel.
Recently, we got a look at some captivating images as Webb peers back toward the origin of everything.
These weren't just galaxies that formed quickly. They were different altogether. They behaved in ways no galaxy ever had. One of the most baffling findings came from spectroscopy, the tool that breaks down light to reveal what something is made of. It showed that some of these early objects had turned all of their gas into stars. That's unheard of. In modern galaxies, only about 10% of the gas becomes stars. The rest lingers in clouds, waiting for gravity and time. But these ancient objects were complete. Nothing left, no raw material, just pure starlight. This discovery rattled astronomers. If an object turns all of its gas into stars, it can't grow any further. It burns out fast. It also suggests a level of efficiency that defies every known process in galaxy formation. The laws of physics, as we understand them, shouldn't allow it. And yet, there they are, glowing defiantly from the edge of time. Some scientists began asking the question no one wanted to say out loud. What if these objects aren't galaxies at all? Maybe they're something new, something we've never classified. Some speculate they could be massive star clusters, ancient quasars, or remnants of a universe that existed before the Big Bang. Others suggest entirely new categories, objects we haven't named because we've never seen anything like them. What's more, these strange structures don't show the same patterns we expect. They don't rotate like galaxies. They don't have the typical spiral or elliptical shapes. They're compact, irregular, and oddly bright, almost like cosmic fossils from a reality we weren't supposed to witness. If they're not galaxies, then everything changes. Because we've built our understanding of cosmic history on the idea that galaxies are the building blocks of the universe. But if these aren't galaxies, then what are they? Whatever they are, one thing is clear. The universe is more mysterious than we imagined. And we may have just glimpsed a chapter that doesn't belong in our current book. Now first, like always, be sure to hit the like button down below. It helps us out tremendously with the reach of this video. Thank you. A limitless universe? When we look into the sky, we're not just seeing space, we're seeing time. Every star, every galaxy shines from a different chapter of the universe's story. The farther we look, the older the light. And with the James Webb Telescope, we're looking deeper than ever before. But there's a limit to how far we can see. Scientists call this the observable universe. It stretches about 92 billion light-years across, a sphere of space centered on Earth. Beyond that, nothing we can observe. Not because nothing is there, but because the light from beyond hasn't had enough time to reach us. Yet here's where it gets strange. As space expands, and it is expanding faster than ever, distant galaxies are moving away from us at speeds faster than light. According to logic, their light should never reach us. But due to the nature of expanding space, some of it still does. It's like watching a balloon stretch, with points on its surface racing away from each other, while light bends and curves along the way.
You know, space is more crowded than you might think, and actually galaxies wind up interacting with each other. They actually will merge together.
This expanding bubble is called the Hubble sphere. Galaxies outside it move away faster than the speed of light. But as the sphere grows, it catches more of that fleeing light. That's how we can still observe galaxies that seem impossible to reach. Still, there's a boundary we cannot cross, the cosmic horizon. Beyond that, no light information ever reaches us, no matter how long we wait. But just because we can't see past it, doesn't mean nothing exists there. Most cosmologists agree that the universe likely continues far beyond what we can observe, possibly to infinity. And if it's infinite, that changes everything. The Big Bang wasn't an explosion in space, it was an expansion of space itself, happening everywhere at once. Meaning the beginning of the universe didn't happen in a single spot. It happened everywhere, all at the same time, even in regions far beyond what we can ever witness. So when we look at the edge of the observable universe, we're not looking at the end of space. We're staring at the limits of our perception, and what lies beyond that edge might be another universe entirely. Time, space, and the beginning. The Big Bang is often imagined as a massive explosion, hurling matter outward from a single point. But that's not quite right. If the universe is infinite, as many scientists believe, it was always infinite. The Big Bang didn't happen at a place. It happened to space itself, everywhere, all at once. That means the beginning of time didn't create a center. It created a moment that happened everywhere in the universe. Even the most distant corners, beyond the observable boundary, were part of that moment, and the light from that moment still fills our sky. We call it the cosmic microwave background, the afterglow of the universe's first light, echoing across all directions. But what if our concept of time itself is flawed? If objects we see today had already formed stars just 200 million years after the Big Bang, then the timeline we've constructed might be wrong. Maybe time in the early universe flowed differently, or maybe these objects weren't part of the beginning at all. Some scientists suggest that our understanding of before and after could break down under extreme cosmic conditions. In those first moments, the rules we rely on today, gravity, motion, and light, might not have applied the same way. That opens up a strange possibility. The early universe might not have a beginning in the way we think. What we call the start could be a transition from something else, something timeless, or something we haven't imagined. If the Big Bang was a phase shift, not a birth, then there could be other phases before it, other realities, other universes. So now we're left wondering, what really happened at the start? And if time has no true beginning, what does that mean for the universe and us? 87 galaxies that shouldn't be. In a recent study published in the Astrophysical Journal, astronomers revealed something that left the scientific community stunned. Using James Webb's powerful eye, they identified 87 galaxies that might have existed just 200 to 400 million years after the Big Bang.
But the James Webb Telescope has identified galaxies that exist 500 million years after the Big Bang.
That number is not just surprising, it's impossible, at least according to our current understanding. Galaxies need time to form. Clouds of gas must collapse. Stars must ignite. Gravity must shape these stars into clusters, and clusters into galaxies. That process should take hundreds of millions of years. But these galaxies appear to have formed in the blink of a cosmic eye. It's like opening a history book and finding detailed cities already built on page 1. Even more puzzling is how many of these galaxies appear well-formed. They're not chaotic or half-assembled. They show structure, brightness, mass, the very traits scientists expected to see billions of years later. If even a handful of these galaxies are confirmed to be real, it would mean that we've misunderstood how galaxies form from the very beginning. One of the lead researchers, Jing Yan, stated it clearly. Even a few confirmed galaxies at this stage would require us to rethink the timeline of the early universe. These objects are too ready, too complete. Some of these galaxies contain more mass than should be possible in such a short time. Others have star formation rates that challenge everything known about cosmic evolution. Together, they form a new mystery, a collection of ancient objects that shouldn't be there. It's no longer a single anomaly. It's a pattern. And with each new deep-field image, James Webb keeps finding more. These galaxies, or whatever they are are sending a message from the farthest reaches of space.
James Webb Telescope has finally confirmed that our understanding of the universe was completely wrong.
And that message is loud and clear. Our cosmic clock might be broken. What do we do now? Faced with discoveries that don't fit any known theory, the scientific world finds itself at a crossroads. Do we patch our existing models, or do we accept that something fundamental is missing from our understanding of the cosmos? Some scientists are already calling for bold new ideas. Maybe dark matter isn't as passive as we thought. Perhaps the laws of physics change in extreme environments. Others whisper even stranger theories: variable speed of light, ancient black holes that seeded galaxies, or quantum effects on a cosmic scale. Each theory tries to explain what we're seeing, but none of them can explain everything. The most radical idea is also the hardest to ignore. What if these objects are not part of our universe as we understand it? What if they're signs of another universe, a separate reality, stitched into our own through some unknown mechanism? If the multiverse is real, these bright early structures could be scars from a neighboring cosmos bleeding into ours. Of course, these are just ideas. Speculations are built on data we're only beginning to process. But this is how science moves forward, by challenging what we think we know and pushing into the unknown. Some researchers are hesitant. They urge caution. They remind us that extraordinary claims need extraordinary evidence. And they're right. But that evidence is mounting, one discovery at a time. Webb was designed to see the universe's first light.
One of the key things that the James Webb Space Telescope is designed to do is detect the very first stars and galaxies that were born in the very early universe.
Instead, it may be illuminating the edge of something even deeper. We're not just rewriting textbooks. We may be rewriting reality. So what do we do now? We look again. We question everything. And we prepare for answers that might feel more like science fiction than science. Because when the universe speaks, we can't afford to cover our ears. We've peered into the deepest corners of space and found questions, not answers. The James Webb Telescope didn't just reveal distant stars, it uncovered a cosmic riddle that may redefine our place in the universe. Galaxies that form too fast, objects we can't explain, a timeline that no longer holds. Even Nobel-winning minds are left in wonder. Is this truly the beginning of time we're seeing? Or something else entirely? Another universe? Another truth? Whatever it is, we've only just begun to understand. And as we stare into that endless night, one thing becomes clear: this mystery is far from over.